All right. So, hi Dhanushri.
Hi, sir.
So let me see. You guys can see the board fine, right?
Yes, sir.
Okay.
Can you move the camera a little to the left, sir?
To the left.
The other way, sorry.
Okay. To the right. Is it better?
Yeah.
Okay. All right. So let me, while we're waiting for everybody else to join, let me do some artwork. And did you guys get a chance to see what is the topic for today?
Is it trigonometry of triangles?
Yeah, so let me just read it for you guys. So the topic for today is trigonometry of angle addition identities. Meaning we learned when we learned about the basic Sukha or trigonometry, right? We learned okay, sine theta is the opposite side divided by hypotenuse. Cos theta we learned something. Then we learned the theorem of complementary angles, right? Where we learned that cos theta is equal to sine 90 degree minus theta, right? Similarly, then we learned the sine cosine laws, right? Which was nothing but when you know two angles and the side, then how do you relate, how do you find out other sides? It was based on the sine, law of sine, which says sine A divided by sine of A or sine alpha equal to B by sine beta equal to C by sine gamma delta, whatever you call it. Let's say this. Gamma will be something like this, let's say. So basically, this was the law of sine. Then we learned the law of cosine when you know two of the sides and one of the angle, and then how do you find other dimension? That is where we learned a square equals to b square plus c square minus 2bc cos of theta, which where b and c are the known sides and theta is the angle between the two sides. Do you guys vaguely recall that?
Yes, sir.
Okay. So, Dhanushri, have you encountered with this before? I know this is your first pre-calculus class, but I'm just trying to see if these things are resonating with you based on what you have learned before.
A little bit.
Okay. Then what I would suggest is you can watch the video of the previous classes and let me know. And wherever there's any doubt, we can certainly try clarifying those. All right. And in today's class, we are not going to talk about the law of sine or cosine or tangent or the basics Sukha we all know. So we will not try revising those. What we are trying to learn today is something like this. If I have, let's say, two angles, alpha and beta, or I kind of get confused with these fancy symbols. So let's say if we have two angles A and B. Okay. So sine of angle A plus B equals sine of A multiplied by cos of B plus cos of A multiplied by sine of B. So this is one addition rule. And again, I'm not asking you guys to memorize this. I mean, when you practice it more, you will get to know about this. Similarly, when you have to find out cos of A plus B, it will be cos of A into cos of B minus sine of A into sine of B. So these are the identities where you add couple of angles or two angles and then you can relate it that way. So here let's say if you know sine of 30 degree equals 1 by 2 and you know sine of 60 degree equals root 3 by 2. This formula also helps you prove this. So anyway, we are not going to the implementation part of it, but first we try to understand what is the trigonometric addition identities for two angles. That's what we're going to learn. So we'll learn how this sine of A plus B equals sine of A times cos of B plus cos of A times sine of B, and how is cos of A plus B equals cos of A times cos of B minus sine of A into sine of B. They are the two trigonometric addition identities, and we'll try to learn why these two identities are valid and how this came into light. Is that part okay? I mean, at least are you clear with respect to what we are trying to find out today? Yes, Arya.
Does tangent have a similar rule?
We can try deriving that. We certainly do. I mean, at least I have not come across that. I can try finding it out. Okay.
Okay, sir.
But one thing, in simplest form, anything of tangent we have to find out. It will be nothing but sine of A plus B divided by cos of A plus B. Okay. So as long as we are able to find this and we are able to find this, tangent is nothing but a derived form of sine and cos, right? So we can always relate it to this one, and if time permits, we'll just try to apply what we learned today into a tangent thing to see what exactly it gets us. Yeah.
Okay, sir.
Dhanushri, Dev, are you guys clear with respect to what we are trying to learn today?
Yes, sir.
So in very simple terms, if I have two angles A and B, what will be sine of A plus B? And there is a formula for that. How that formula comes into light, we'll find it out. Similarly, if you have two angles A and B, and then how do you find out cos of A plus B? So that's what we are trying to do today. So let's, whatever I said, keep it in your memory to the best possible extent. If you forget, don't worry about it. Math is not about memorizing things. So what I did was, I was trying to flex my drawing skills. I have just plotted a diagram here. What exactly I'm trying to do is, let's say this is my angle A. Okay, I'm using small letters so that we don't get confused between the capital A and small a. Okay, so this is my angle A, and this is my angle B, small b. Okay, what we are doing, so this total angle from here to here will be A plus B. Everybody with me so far?
Yes, sir.
Okay. Now, if I have to see what is our goal, we are trying to find out. We are trying to find out sine of A plus B. Yeah. So when you look at sine of A plus B, we are essentially talking about. Let me color this triangle so that it doesn't create any confusion. when we are talking about sine of A plus B, we are essentially talking about, and remember this is all right angle, okay, 90 degree, this is also 90 degree. Okay, so what I have done is, I have drawn a right angle triangle so right angle triangle ACD. This has the angle alpha, angle A, and the large triangle ABE, which has the angle A plus B. I'm just writing it for the sake of clarity. So basically, this is my small triangle which is making this angle A, and this is my large triangle, the one that I've shaded as green, which is making angle A plus B. Yeah. And now, if you look at it carefully, what I've done is I've just extended this line and have drawn a perpendicular from here to here, so that triangle ABC has angle B. Are you guys able to visualize this part? This is my angle triangle ACD, first one, which has this angle A. This is the shaded triangle is ABE, which has the angle A plus B, and this is my third triangle ABC, which has the angle B here. I will let you guys process this part looking at the diagram before I move on. Is that not clear?
Yes, sir.
Okay. Dave, with me?
Yes, sir.
Okay. So all that I have done, right, is just to let you guys visualize how I have drawn this, how this diagram has come into existence. Okay. So this is my small triangle which has this angle A. This is my large triangle which has angle A plus B, and this is my third triangle which has this angle B here. Okay. And all these three triangles are right angle triangles. Only thing I have done is, from this point I have drawn a perpendicular here, so that this line FC is parallel to line AD. Yeah. So this is just the drawing part. Okay. This is all about my drawing skills, nothing more. Yeah. Now let's go to the actual work that we are wanting to do. As long as we have visualized it clearly, whatever we will do now will not look that complicated. Now let's look at sine A plus B. So essentially we are talking about the green triangle. So this green triangle A plus B, this is my angle. So sine of A plus B will be what? This height, the side opposite to this angle, divided by the hypotenuse. Agree? BE divided by AE. Oh, my bad. By AB. So this side divided by this, by the SOHCAHTOA, right?
Yes, sir.
Now BE. This BE is what? This piece plus this piece together. So I can say, instead of saying B, I can say BF plus FE. Plus FE divided by AB. I did not do anything fancy, okay? I just split this line into two pieces. That's it. Yep. Everybody with me?
Yes, sir.
Now, so this means I can split this. This becomes BF divided by AB plus FE divided by AB. Yeah? So for simple stuff, so by this, look at this triangle, sine of A plus B is equal to this side divided by this side. So opposite side divided by the hypotenuse. and this opposite side is mix of this piece plus this piece. So that's what it is. I have just split this. So far it's clear? Okay. I mean, I will always wait to hear a yes from you guys so that I get the confidence to move on. So I'm just creating some real estate here. So I'm just moving this line up. It becomes BF divided by AB plus FE divided by AB. So I just copied, pasted. I did not have a Control C, Control V option. So that's what I did. Now BF divided by AB plus FE or EF divided by AB doesn't make much of a sense to us, right? Now, what we want to do is get something meaningful out of it. Now let's look at it this way. Now if I have BF divided by AB by this. So BF by AB has nothing that we can relate with SOHCAHTOA. Same way FE divided by AB. I mean, we don't see any relationship. These are all different disconnected triangles. They don't have any relationship. But we can certainly look at, now let's look at this, BF. BF is part of, see, this is another right angle triangle. If you look at it, right, this is BFC is another right angle triangle because we have drawn a perpendicular to here. Now if you look at this BF, if I relate to this triangle, we'll be able to make some sense. But how do we do that? First, let's look at some. So this theorem, right? The proof of this theorem is has more to do with visualization part of it. So let's look at it. Now, let's first look at all the angles. If you look at this line and this line, these two are parallel, FC and AD. This is parallel, right? So these are opposite internal angles. So this, if this is A, this angle is also A. Agree?
Can you show that again, sir?
So look at this. This line I have drawn perpendicular from here to here. So this is a right angle triangle. I'm trying to find out the angles. See, let's look at all the angles. We know this is A plus B, and this part is B. Here to here is B. Now, if I look at this triangle, we are trying to find out the angle of different right angle triangles that we see, right? So I'm saying if this angle is A, this angle will also be equal to A because these two are parallel lines and these are opposite internal angles. Yeah?
Okay, sir, makes sense.
Yeah. Now, if this is A, what is the value of this angle? 90 degree minus A, because this is right angle triangle. Yeah. So this angle that I have coded green is 90 degree minus A. Okay, so we got this angle, we got this angle. Now let's look at, so we got some values here for the angles. Now if I say BF by AB, still, I mean, we know with respect to this angle, but probably not helping much. What would help is if I somehow get this part, BC, then I can relate this BC and this one as per the SOHCAHTOA. So what we'll do is, let me make it, so we are talking about BF by AB. So, okay, so whatever I'm doing right now, okay, this might look stupid, but there's a reason for doing it. So this part, okay, what I did is I converted this. because this BF was not helping me much. But I know that this is part of this right angle triangle, so I'm trying to relate this side with this one. And if I have to include this part, so BF by BC will be something as per Sukatua. So I did that. Since I added this one, so basically I have divided and multiplied by BC, multiplied and divided. So this whole value doesn't change for me. Does it make sense? Okay, so let me do one thing, okay? Let me just complete this equation and then I will probably try explaining it. So this is coming from this part. Now FE is nothing but same as, so if you look at this, FE equals CD. Okay, so instead of FE, I will say CD. Okay, now what will I do? I will say or let me do some magic here. Okay, so if you look at this was our initial equation, okay? BF by AB plus EF by AB. So sin A plus B was this divided by this. We just split this part into this plus this. So that's what we are seeing here. Now what I have done is, I have not changed the value here, okay? I just, for the first one BF by AB, what I did was, I said BF by BC into BC by AB. I just expanded this because I can anyways knock off these two whenever I want, right? So I have not changed the value. Similarly here, what I did was, I had FE by AB, I just multiplied and divided by AC. So I have not changed the value here. So this and this I can always knock off. So my value has remained the same. I have just expanded this one to get some meaningful outcome from this. Confused? Okay. No, it's okay. I mean, I know these are little complicated things, okay? This might look complicated to begin with, but I'm just trying to, okay. Okay, so this is, again, I start in the beginning, okay? Look at this. This is my angle A. This is making in this triangle, this one, ACD, okay? And this is my angle B. So what I did was, I extended this to a point where this is perpendicular. So then ACB, this is also a right angle triangle. This is a right angle triangle, this is a right angle triangle. And now, if I look at this total angle, which is A plus B, so this is another right angle triangle, ABE, okay? So we have just drawn this diagram. Now what we did was, we are saying, okay, fine, what we have to find out, sin A plus B. So this is my angle, this is my right angle triangle. So sine of this is this side divided by this. This side is this plus this. So that is how this by this plus this by this, hypotenuse. Yeah. Now when we got this BF by AB, FE by AB, BF by AB plus FE by AB, which is just a split. Now this is, again, when we look at this diagram, things are a little complicated, okay? So we are saying, okay, fine, this BF doesn't hold any meaning for me. It is not part of any, it's only part of this right angle triangle. So for getting this one, what I need is, okay, if I somehow bring this guy into picture in this right angle triangle, then I will be able to relate it with some sine or cos value based on Sukatua. So what we did was, we first found out, okay, this is A, angle A, then this is my angle A as well, because these two are parallel lines. These are opposite internal angles. If this is A, this is this 90 degree minus A. So now in this right angle triangle, I know this is my angle, this is my side, and this is my hypotenuse. So if I have to use this side, I'm trying to bring this guy into picture so that I can use SOHCAHTOA somewhere here. Now my angle is this. This is my side, which is nothing but BF, and this is my hypotenuse. But this hypotenuse is not in the equation. What I will do is, let me say, okay, BF doesn't exist by itself. Let me look at this triangle, BF by BC. If I do BF by BC, then I can bring the sine or cos for this triangle, right? So if I am dividing this by BC, then I will get probably sine or cos value here. I have this side and I have the hypotenuse in this triangle. But BC was not there with us. So if I am dividing by BC here, I have to multiply by BC here. So my overall value doesn't change. Similarly, if I look at this FE and extend it till here, my FE is nothing but same as CD. And now I can relate with this triangle. So I got this side, I know this angle. So I can use this side and this hypotenuse of this right angle triangle to get some sine cos value here. So I got CD by AC. So CD. Now this FE is nothing but my CD. This same value. Okay. CD by AC. So I'm bringing AC here in the mix. Now when I do AC, I'm dividing by AC, that means I have to multiply by AC also, so that my overall value doesn't change. Is this part clear so far? Are you guys able to follow me?
Yes, sir. Yes, sir.
Dev?
Yes, sir.
Okay. No, and if you find this cryptic, maybe you can watch the video also after the class. That might help. But now, with whatever equation I had, now we have something here. Now look at this. When we got this one, related with this triangle, we got this guy into picture. When I'm bringing this guy into picture as a denominator, I have to put a numerator as well. Similarly, when we are looking at this piece, this is equal to this one. So I'm looking at this triangle now. When I'm using this one, I have to divide by this hypotenuse. When I'm dividing by this hypotenuse, which is AC, then I have to multiply by the same thing. So now I have not changed the value, but I have something meaningful that seems to be the case. Now let's look at this. BF by BC, BF by BC, BF by BC. And this is the angle that is known to us. This side is opposite to this angle. So this is sine 90 degree minus A. This angle was 90 degree minus A. So sine of this angle, meaning this by this, sine of 90 degree minus A. BF by BC is sine of 90 degree minus A into BC by AB. What is BC? BC divided by AB. Now we are looking at this right angle triangle where this angle is B. So BC by AB. BC by AB, as per SOHCAHTOA, this will be BC, the side opposite to B. So it's sine of B. First one, BF by BC. This is BF is opposite to this angle. So sine of 90 degree, and BC by AB, BC by AB in this right angle triangle. BC by AB is nothing but sine of B, because this is by angle B. Similarly, this part will become CD by AC, CD by AC, CD by AC. This is nothing but this is by angle A. CD by AC will be sine of A into AC by AB. What is my AC? AC by AB. Again, this is B is AC. Sorry, AC by AB. This is my angle B. So this is base adjacent side by hypotenuse. This is cos of B. So here sine 90 degree minus A. This is based on the rule of complementary angle. Sine 90 degree minus theta is cos theta. So this will be cos of A into sine of B plus sine of A into cos of b. So this, if you remember, when we are looking at this formula or this identity, it says sin of a plus b equals sin of a times cos of b plus cos of a into sin of b. Cos of a into sin of b plus sin of a into cos of b. Now this was a cryptic exercise. So again, if you look at, do a recap of all that we did. We made an angle A. This is my right angle triangle, and we made an angle B. We extended this to make it a right angle triangle as well. So this is my angle B, this is my angle A, and this total angle is A plus B. What we did, we said, okay, fine. This is my right angle triangle which has this angle A plus B. So sine of A plus B equal to opposite side divided by hypotenuse. My opposite side is this length, which is this plus this. So BF by this. BF by AB plus FE by AB. Now this FB and this is same. So we replace this by this. Now BF doesn't exist by itself. We looked at this right angle triangle and say, okay, fine, BF, and this is my hypotenuse for this right angle triangle. So if I bring this into the mix, then I have to multiply by this same thing. Similarly, when we looked at the second part, FE, which is CD by AB, this CD by AB doesn't exist by itself. So CD is part of this triangle. So CD by hypotenuse, we divide by the hypotenuse. That means I have to multiply the same thing so that my value doesn't change. So it helps me split this. So once I have split this, BF by BC is, this is the opposite side to this angle. This is 90 degree minus A because this was A, so this is 90 degree minus A. So this is 90 degree, sin 90 degree minus A. BF by BC became 90 degree minus sin 90 degree minus A, and then BC by AB became, this is part of this triangle, so this became sin of B. Similarly, this part became sin of A times cos of B, and then this formula came into life. So in summary, this is the identity with sign, which says sin of A plus B equals sin of A times cos of B, and then you flip, say cos of A times sin of B. Very loaded information, isn't it? Or were you able to follow what I said or what I did?
Yes, sir, I was able to follow.
Okay, how about you, Dave, Dhanushri?
Yes, sir.
Okay. So, now, all that we did for last 30 minutes was only to prove one small thing, which says the sign identity of trigonometric addition of angles, sin of A plus B equals sin of A into cos of B plus cos of A times sin of B. Okay, and all that we did, you guys can always revise and do a recap. And the best way to do it is draw this by yourself, okay? Because teacher will forget, you will see, you will forget. So just do some scratch work, and just to be honest with you guys, before I was trying to explain this, I myself, I was actually, when I asked you guys for 15 minutes extra, I was actually drawing it myself, just to be doubly sure about not missing any other steps to get you guys confused. Okay. So best way to do math is by getting your hands dirty. So this is the first identity. I am assuming that we are all clear about this one. Yeah. So if somebody tomorrow gives you two values, right? Sine of, let's say, gives you angle A equals 30 degree and angle B equals 20 degree. Find out sine of A plus B. So what you know is, either you can add these two and say, okay, sine 50 degree equals to what, or else you can apply this identity formula and do this. Yeah. Now let's go to cos of A plus B. This equals cos of A times cos of B minus sine of A times sine of B. Now you will say how? Thankfully the same diagram helps. Okay? So here let's try proving this. Now again, when you look at cos of A plus B, right? If you were able to follow what I was doing just before, you'll be able to kind of connect the dots and will be able to help do the same thing, follow the similar steps. So if I say cos of A plus B, what we are essentially talking about is in this triangle A plus B. So this is my cos of A plus B. Now when you say cos of A plus B is nothing but the base, the adjacent side. If this is my angle, cos of A plus B as per Soka law will be this side divided by AB. So this side is what? AE divided by AB. Yeah. Now this AE is nothing but this length minus this length. So I can say, instead of saying AE, I can say AD minus ED. AD minus ED divided by AB. Yeah, same thing. So instead of saying AE, I am saying this length minus this length, which is this length. Yeah. So this becomes, I can say AD by AB minus ED by AB. So AD by AB minus ED by AB. Now again, same problem, right? These are hanging, without any relationship. But we know this ED is equal to this part, FC. So what I will do is, in the next step, I can say AD, again, AD is part of this triangle, right? So this one I will not touch probably, by AB minus ED. This ED, it doesn't belong here, it belongs in this triangle, right? And this ED is equal to this one because these are parallel lines. So ED equals FC. So instead of saying ED, I will say FC divided by AB. Up to this is fine, right? So again, recap. This is the diagram, this is my angle A, this is my angle B, this is A plus B. So we are saying cos of A plus B. A plus B, this is my angle. Cos of this will be this divided by this. Yep, yeah, Dhanushri.
I have to go.
Yeah.
Is that okay?
Yeah, sure. So basically, I'm just extending what I did, and whatever you're going to miss for next 15 minutes, you can just watch this video to make sure that you're able to follow it. And the best way to do it is by drawing it yourself and getting your hands dirty. Okay.
Okay, sir. Thank you.
All right. So now I have AD by AB minus, instead of AD, I'm saying FC by AB. Yeah. Now these are again this piece, this piece, this piece, this piece. It doesn't have much relationship. But if I'm looking at AD is nothing but a part of this triangle. So let's look at this. AD by AB has no meaning, but AD by AC gives me what? Cos of A. So I will do, instead of saying AD, I will say AD divided by AC. Now since I have divided, I have to multiply also, and AB remains AB. Yep. Similarly for this guy, FC is part of this triangle. So if I do FC divided by BC, then I can apply Soka law, right? So FC divided by BC, FC divided by BC. Then I can apply Soka law. Since I divided by BC, which was not there before, so that means I have to multiply also. Yeah. So if you look at it, right, whatever I'm doing, these are very simple stuff. It has more to do with the visualization part of it. How do you get sine cos A plus B? The base by height, base by hypotenuse. Now this base doesn't exist by itself. This base I can say this minus this. That's what I did. And I split that. Once I split that, this is not cutting ice for us. This doesn't exist by itself. AD is this. This is part of this triangle. So this divided by this gives me something with SOHCAHTOA. If I'm dividing by AC, then I have to multiply by AC also. So then this value doesn't change. Similarly here FC is part of this triangle. So FC by this gives me something for SOHCAHTOA. Since I'm dividing by BC, I have to multiply by BC also. Yeah. Now look at this. AD by AC. AD divided by AC. What is this? This is angle A. AD by AC is nothing but cos of A times AC by AB. AC by AB. Again, this is part of this right angle triangle. AC by AB is nothing but this is angle B. So this is cos of B. Minus FC by BC. FC by BC. Now we know that this is my angle 90 degree minus A. FC by BC. It's sine of this angle. Cos of this angle. So cos of 90 degree minus A. 90 degree minus A. Times this one. BC by AB. BC divided by AB. Now this is angle B. So BC is opposite to this angle B. So this is sine of B. So if I move this equation's value here, let me create some real estate here. So this is cos of A times cos of B. This equals cos of A times cos of B minus cos 90 degree minus A. So this is rule of complementary angle. Cos of 90 degree minus theta is sin theta. So this is sin of A times sin of B. So this is the second theorem or identity which says cos of A plus B equals cos of A times cos of B minus sin of A times sin of B. So we learned to again. So here same way when it was sine, we looked at this angle. Sine of this is this by this, and this can be split into two parts, and then we just applied that magic of dividing common things and multiplying, multiplying common things. And again it was nothing cryptic. When you look at these pieces, look at which triangle is part of and try mapping it with the hypotenuse. That is how we got, in case of sine, we got sin of A plus B equals sin of A times cos of B plus cos of A times sin of B. And then in case of cos of A plus B, we found that same thing, this is the triangle, cos of this is base by hypotenuse. So base is this minus this, and then we kind of split that and looked at this piece is here, this piece is part of this triangle, so this again related with the hypotenuse, and then it gives you cos of A plus B gives you cos of A times cos of B minus sin of A times sin of B. So these are two identities we learned, and we learned how those values are derived. I would have, or I could have just written these two formulas and say, okay, memorize this. That is enough. But instead of doing that, which is disrespect to math, we tried figuring out how that formula came into existence. Were you guys able to follow it?
Yes, sir.
Okay. So again, these formulas you will learn, you will remember, and you will apply. But then the success of how much you will remember, recall and apply depends on how you draw this. It's very simple. Angle A. Okay. Draw an angle A. This is your angle A. Now you want to do A plus B. So draw angle B on the top of this. And then make this another right angle triangle. So this is a right angle triangle. This B is making a right angle. This B together is making a right angle triangle here, A plus B. Now, what you want to do is you want to draw a perpendicular here So you are essentially talking about 3 right angle triangles. This one, and this one. Now, only thing you did was you had drawn a perpendicular from this point to this point. So this gives you a 4th right angle triangle. As long as you draw this and visualize this clearly, you'll be able to prove it by yourself as many times you want to. So there's nothing new that we have learned here. These are basic SOHCAHTOA or basic trigonometry rules that we have learned, and we have just applied that to get these identities. Now you will say we have 10 more minutes. So let's look at what we learned and how we can apply that. Let's look at some cool stuff. So what we learned was this: sine of a plus b equals sine of a times cos of b cos of b plus cos of a times sine of b. And second thing we learned was cos of a plus b equals cos of a times cos of b minus sine of a times sine of b. Yeah, this is what we learned. Now, if I say find out sine of 2a, you can simply apply this. So sine of 2a you can always say will be equal to sine of a plus a. Yeah. And now you know sine of a plus b. Sine of a plus b, again your b and a are same. You can apply this thing and say sine of a plus b equals sine of a times cos of b plus cos of a times sine of b. So sine of a times cos of b, your a and b are same, plus sine of b, again your a and b are same. So instead of saying cos of a, you will say cos of b, you will say cos of a. So it becomes 2 times sine a cos a. Sine of 2a equals 2 times sine a cos a. You just apply the formula and you were able to get this. Similarly, if you have to say find out cos of 2a, again you know that cos of 2a will be nothing but cos of a plus a, and that equals cos of a times cos of b, again your cos of a and b are same, minus sine of a times sine of b, again your a and b are same. So it becomes cos square a minus sine square a. Yeah. Now, so cos of 2a equals cos square a minus sine square a. And we have done nothing. We just split that into 2 parts. Tomorrow if you have to find out cos of 5a, you can, yes Arya.
So for sine of 2a, wouldn't it be 2 times sine squared of a?
No.
Oh, never mind.
Yeah.
Wait, so, okay.
So again, if you recall it, sine of a plus b is sine of a times cos of b plus cos of a times sine of b. Here the beauty is your a and b are same. So you will just replace every b with a. So it becomes sine a cos a plus cos a sine a. Sine a cos a, sine a cos a. So 2 times sine a cos a. Yeah?
Okay, sir. Makes sense.
Now, similarly, cos of 2a gave you cos square a minus sine square a. Same thing. You just apply this formula or this identity, whatever you call it. Now, if you want to represent cos of 2a in the form of cos a alone, now we know another identity which says sine squared theta plus cos squared theta equals 1. Right? This is something that we have learned before. Now you can apply it here. If you want to represent this in the form of cos a only, you will replace this with using this formula. So this sine squared a becomes, you can always say minus sine squared is nothing but 1 minus cos squared a. Yeah? It goes that side. Sorry, sine squared a becomes 1 minus cos squared a. Now here you break this down. Cos squared a minus 1 minus into minus plus cos squared a. It becomes 2 2 cos square A minus 1. So cos 2A became 2 cos square A minus 1. Yeah. So all these are identities. They will become more like a thumb rule that you can apply for finding values. Let's say if you know the value of cos 30 degree, okay, you can apply it here, cos 30 degree. So let's say if you know cos 30 degree is root 3 by 2. So what is the value of cos 60 degree? You will say, okay, fine, this equals 2 times cos square A. So it equals 2 times cos square A, square of A, root 3 by 2, minus 1. So 2 times root 3 square is 3, 2 square is 4, minus 1. 2 3 is 6 minus 4, sorry, 2 3 is 6 by 4, minus 1. And you can find out the value of this, which will be nothing but 4, 6 minus 4, 2 by 4, 1 by 2. So we were able to get the value of cos 60 degree. Did we get it right? No. Yeah. Sorry. No, sorry. We got 1 by 2. My bad. That's what I was thinking. How come we got 3 by 2? 2 by 4 gives you 1 by 2. Yeah. So if you know value of cos 30 degree, you could derive the value of cos 60 degree. Right? So likewise, I mean, a classic example could be if you know the value of, let's say, sin 60 degree. Can you derive the value of sin 80 degree, 180 degree? Yes, you can say, okay, this equals sine of 60 degree plus 120 degree. And then you can go on splitting. So basically, all these identities will become more like a formula which you can use for finding out the derived values or apply wherever needed, right? So we learned 2 basic formulas: sine of A plus B equals what, sine of cos of A plus B equals what, and how do we apply that for deriving the values or playing around with that in different ways. Yeah. Was this part clear? Now, Dev, Arya?
That's pretty clear, sir.
Okay. Arya, was it clear?
Yes, sir, it's clear.
Okay, wonderful. Then I will let you guys go. But before you guys go, okay, one last thing. So Arya, you had asked, how do I find out? Do we have identity for 10 of A plus B? So 10 we don't find out separately. We can always say sine of A plus B divided by cos of A plus B. And then if you look at it, sine of A plus B is sine of A times cos of B plus cos of A times sine of B. And then cos of A plus B gives you cos A times cos B minus sine A times sine B. So from this you can derive, or the same magical diagram that I have drawn. So A plus B, this is A, this is B. So 10 of A plus B will be what? This divided by this. So we can apply the same formula here, same way, right? Same approach we can take. This by this gives me the value of 10, and then we can probably map it to these triangles, and same approach we can do. So this part is nothing but this minus this, and this part is nothing but this plus this. So again, same thing, same approach. You get that value of 10, and then you split that, and from that you can basically again see which triangle it maps to, and keep looking for the, again, since you're talking about 10, so you might want to look at the different right angle triangles and try finding out how do you relate which part you can multiply and divide, which side you can multiply and divide to convert that to sine, cos or tan form. Yeah.
Yes, sir.
All right. So with that, I will let you guys go. Enjoy your dinner. Have a good night's sleep. And when you get time, just watch through go through the video once, and then try practicing it by yourself. These are the concepts that those are handy, and I'm sure we don't get to encounter these very often. All right.
Okay. Thank you, sir.
Yeah. Bye bye. Good night.
Thank you, sir.
Yeah. Bye bye.